Now this question says that is it possible for an object to be in motion and have zero net force acting on it? Yes, it is possible. It is possible. Why? Let me explain. If net force acting on an object is zero, that means the acceleration is zero. This is acceleration. If net force is zero, so acceleration is also zero. Now if acceleration is zero, the velocity is constant, right? Suppose this scooter is moving with constant velocity v. So net force acting on this object is zero. That is why it is moving with constant velocity v. So yes, it can be possible. Now in this question we are given that a person jumps from the cliff of a mountain and perform a perfect swan dive. Now the earth exerts the force on the person, the gravity force, in the downward direction, and by the Newton's third law the person also exerts an upward force on the earth equal in magnitude. Suppose this is the earth, so person will also exerts the force in the upward direction with same magnitude. But here the question is that why does it seem that you are the only one doing all the accelerating? Since the forces are the same, why aren't the accelerations? If you see the free body diagram for earth, force will be exerted by the person, but this acceleration is net force over the mass for the earth, and the mass for the earth is huge. This value is very large as compared to this force F. So acceleration is very less or tends to zero. That is why it seems that you are the only one accelerating in the downward direction, not the earth. So this is the required solution. So in this question it says that objects in outer space or orbits are weightless. So how it is possible for an orbiting astronaut to tell if one object has more mass than the other object? Now it's pretty simple. So suppose we have two objects, one with heavier mass and another with less mass. Okay, an astronaut can easily tell by pushing with the same force on both the object. So the object having more mass can be recognized by its smaller or less acceleration, because we know that acceleration is net force acting on an object divided by the mass. So more the mass, less the acceleration. So easily we can tell that which object has more mass and which object has less mass by observing the acceleration. So in this question we have two cases. Case 1, when a person step off a high board and drops to the water below, that you can see in this image, and plunge into water without injury. Case 2, this was the case 1. Now in case 2, the same person jumped from the same height but this time on the solid ground. In this case he might break his leg. Now we have to explain this difference using Newton's laws of motion. So on solid ground the person comes to rest in much smaller distance when compared to water, and the smaller the distance over which the person comes to rest, the greater will be the acceleration, and greater the acceleration, the greater will be the force applied on your legs, and hence this large force may be enough to cause injury, and that is why in this case you might break your leg. This question says that the bucket of water is weightless in space. That's true. So if you kick the bucket of water with your foot, will it hurt you or not? This is what we have to explain in this question. So of course it will hurt you, no doubt in this. Let me explain. Even though the bucket is weightless, it still has mass. So if you exert some force on bucket, it will resist the motion by exerting an equal and opposite force on your foot, and this force can be painful. Thus definitely kicking the bucket will hurt you. Now in this question we have to list 3 common objects that have a weight of approximately 1 Newton. So 1 Newton is equals to 0.224 pound, or nearly a quarter of a pound. So if you take some of the common examples in your day-to-day life, it can be a glass of water, it's around a quarter of a pound, so it weighs 1 Newton. Another example, you can take an apple or a couple of bananas. So these are the common examples. So in this question we are given that we have an object of mass m and its initial velocity v0 is 0 because it is initially at rest. Okay, now after a force of magnitude f, so a force of magnitude f is applied for a time interval of t, then the speed of the object becomes v. This is basically the final speed. Now suppose the mass of the object is doubled, so mass becomes 2 times and the magnitude of force increased by 4 times, so this becomes 4f. Then in terms of t, how much time does it take for the object to accelerate from the rest to speed v? So how much time does it take for the object to have the final speed to be v? Now this question is simply an application of Newton's second law of motion. So acceleration in this case, this would be sigma f net over the mass, right? F net, we have only one force f, mass we have m. So acceleration in this case is f over m. Now in this case, acceleration will be force becomes 4 times and mass becomes 2 times. So let it be a2 and this becomes 2 times f over m. Now f over m is a, so we can write that this time the acceleration becomes twice of the previous value. Now if you use the kinematic equation, which is v equals to v0 plus at for the first case, here the final velocity becomes v, initial velocity we have 0 and time taken is capital T. So in this case v equals to a times t, and in this case v would be equals to v0 is 0, a this time is 2a times t, we have to calculate, let it be t2. Now the final velocity is same in both the case, v and v, so we can equate these two equations 1 and 2. So we can write that a times t is equals to 2a times t2, and this t2 is a new time. This a and this a will cancel, and from here we'll get t2 to be equals to t over 2. Therefore the time becomes half. So in just half a time the objects attain a velocity of v.